Hello and welcome to United Astronomy Club of New Jersey. Since it's astronomy time again, our presentation tonight is going to be What's Up in the February Sky with Lonnie Bunis. He has been presenting the What's Up series at UACNJ since it opened in 1994. He's been an amateur astronomer since age 10 and still has his first telescope. He holds 2 degrees from Stevens Institute of Technology in physics and computer science, but thinks his practical experience doing space art, space animation, and virtual reality objects is more important. Lonnie has written the first interactive astronomical history book, Space History Mysteries Solved, which contains 2 movies narrated by Jan Bunis. The smartest thing he ever did was to marry his narrator. She keeps his feet on the ground while his head is high above the clouds. We'll take a look at bright, colorful stars and the giant stellar birthplace near one of the most familiar constellations. Some famous signs of the zodiac, the winter Milky Way, and more as we see what's up in the February sky. And welcome, Lonnie Bunis.
Thanks very much, Kim, and also to our hardworking crew from the UACNJ behind the scenes, Jeff and Chris. I want to thank all of the Kim and all of the amateur astronomers at UACNJ for making this possible. There's a lot going on behind the scenes, my friends, that you don't see, and that helps make this all go smoothly. So if you enjoy tonight's presentation, I hope you'll do 2 things. I hope you will come back for more, because we do this every month, as well as other talks with other topics each Saturday. And I hope that you'll come back and visit when it's physically possible at our home base in the Hope area, Hope, New Jersey. And I also hope, third thing, I lied, the third thing is I hope you'll make a volunteer contribution because we are run entirely by volunteers. So with that, let's find out what's up in the February sky, which I mislabeled star stuff. Sorry about that. When you're visiting the UACNJ, which is open for physical visits normally between April and October, otherwise too cold, then there's things we ask you to do. But since you're not doing that tonight, we're going to do things virtually. We won't be serving you astronaut ice cream virtually. We'll let you use your imaginations for that. And it's a good idea when you are viewing objects that are dim in the night sky to keep your night vision preserved, and that's done by using a dim light. I had a recent presentation that explained why dim red light isn't necessarily the best. We'll do that again sometime. So first, let's talk about how we can get a nice dark sky. UACNJ has some of the darkest skies in the state of New Jersey. It's probably the darkest observatory and observing site in the state, or among those. And it's going to be threatened from not just hundreds, but thousands of artificial satellites shortly. I've got some information from Sky and Telescope magazine, which is also online at skyandtelescope.org, talking about the Starlight satellite program and other artificial satellites that are going to give us a broadband connection to the internet over the entire world, and especially to the disadvantaged areas. It comes with a price, though. Right now, Starlink has 952 out of 1,015 launched satellites that remain, and they're going to up that. They got an approval to launch anywhere from 12 to 42,000 satellites total in low Earth orbit, which means only less than a few hundred miles above the Earth. Now, that's not really outer space as we know it. Our satellites that follow the Earth at the same rate that the Earth rotates are called geostationary, and they help us with our internet connections, communications. Those are 22,000 miles. So you see there's quite a bit of difference for these low orbiting satellites. There are other companies like OneWeb which currently has 74 satellites for communication for internet, but they've got approval to do over 6,000, as does Project Kuiper through the Amazon company. Starlink is a SpaceX, by the way, which has launched private commercial flights to space. So, in other words, the number of artificial satellites that will be littering our skies are, as we say in science, a lot. There has been a recent proposal to the United Nations Committee on the Peaceful Uses of Outer Space to try to control or regulate the way that these satellites are launched and the number that they can be limited to. That proposal is recently been sent to the United Nations, and it's currently under consideration. So we'll see what comes of that. We'll see if we can protect our skies from being littered with too much light or interference from satellites. Observatories need clean, clear skies, and they can't have thousands of interfering objects getting in the way of the faint objects they're looking at. Satellites like those launched by OneWeb are going to be higher in orbit. The higher they are, the slower they move around the Earth, the longer there is time to ruin the skies for long exposure photographs or imagery. Now, my favorite topic for the month, I have to warn you, this may be a short presentation tonight because the amount of stuff that's happening in the February sky this year, not a whole lot. We had a mini moon. Did any of you hear about this? Anyone, raise your hands. I can't see you. I'm going to imagine that you're actively participating. I see some of you with pen and paper. But does anyone know what that is? You know what this is, a pen, pencil? How about a tablet? How about computer, laptop, phablet? All right, take notes. We just lost our mini moon. We had a mini moon that was launched on the 20th of September, 1966. It was actually a soft landing space probe to the moon. The specific area, Sinus Midi, sinus means sea, because long ago people thought the dark spots on the moon were water, and we now know them to be frozen lava, seas of lava. So what happened was there was a big course correction that failed. It unbalanced the spacecraft, and instead of landing on the moon, the soft landing space probe crashed on the moon, and the capsule that was carrying it, the upper stage of a central rocket, missed the moon, went into orbit around the sun. But it was a special kind of orbit. Now, this impact, just a little side note, weighing 644 pounds at a speed of 2.6 kilometers per second. Yes, folks, that's like 6,000 miles an hour. That's enough to make a pretty sizable crater, similar to the impact of spacecraft that I saw crash into the moon when I was a kid. We had a black and white one small black and white screen about 18 inches across, small, up in the corner of the room. We all watched, and we saw the moon images getting closer and closer and closer, and then boom, nothing, as the Ranger crashed into the moon. The Surveyor 2 was supposed to soft land to get more data about the moon, but this one didn't make it. We now call it 2020 SO. Very appealing name. If any of you in the audience have a better name for our mini moon, please submit it to NASA. So here's an animation of the orbit of this object, 2020 SO, in the past year or so. It's an upper stage booster rocket, as I mentioned, a Centaur rocket, fairly large, and we lost it sometime after 1966. We lost the location as it went into its own independent orbit around not only the sun, but in resonance with the Earth and moon, making a weird looping structure like this. Cool. Now, in the reference frame of either the sun or the Earth, this can look different. Einstein showed us that everything's relative. So relative to the sun, the orbit of SO, or 2020 SO, which some people call SO 2020, take your pick, you can watch the time lapse in the upper left of this picture showing what happened in 2019 and 2020 when the object was recovered after 50 years of being missing. You see how it comes close to Earth occasionally, intersecting at some point, and then coming apart again, coming very close, moving away. Now that's in the reference frame of the sun, with the sun stationary. Now what if we look at it compared to Earth? It does this weird looping structure, a sort of an orbit, and that's why astronomers were calling 2020 SO for the past month or so a mini moon. Here's the path. I'll let that run. So you see some figures here showing the speed in kilometers per second, right? We can walk at 4 miles an hour or 6 kilometers an hour. An hour has 3,600 seconds in it, right? 60 minutes, 60 seconds, 60 times 60, 3,600. So in other words, these things travel, as we say in science, fast. If you read Douglas Adams' Hitchhiker's Guide to the Galaxy, he describes it very well. The universe, he says, is really, really big. That's science terminology for you. So you see, compared to the Earth-Moon system, yellow moon, blue Earth, 2020 SO is sort of a mini-moon that hung around for a while. But this configuration, this orbit is not stable. And so we have lost the mini-moon. It's on its way to a permanent orbit around the sun. And it was put really well by a writer, a guy who writes for Reader's Digest magazine, science writer Brandon Spector, who at space.com, very good reference, I urge all of you to check it out occasionally, Farewell to the Mini-Moon. For Brandon Spector put it, I think, as would a poet. This reads like poetry to me. Godspeed, Mini-Moon 2020 SO. We built you, we abandoned you, and now you abandon us. So if you want to find out what's up in the February sky, don't look for the mini-moon. You won't find them. Her, it, seasky.org. Easy to remember. What's up in the sky? What's happening at the sea? Seasky.org puts it all together. It's free, and it has a great calendar of astronomical events that I should have updated to 2021. But hey, how many of us are still writing 2020 on checks? Does anybody still write checks? Oh man, I'm having trouble keeping up with technology and changes. So in the year 2021, you can find the astronomy calendar by going to See Sky and clicking on Explore the Sky, and then clicking on the second tile, Astronomy Reference Guide. There's a lot of stuff at this website. I'll tell you, you can get lost in it as you would browsing anywhere on the web. But click Astronomy Reference Guide, and then you can be really confused with the menu on the left, but just go for the astronomical calendar. Pick a year, past, present, future, 2021. Not a whole lot going on, as I mentioned. The moon was full recently at the start of the end of January, the start of February, but after the course of a few days, February 11th, the moon will be close to the sun in the sky, which means the source of light is where? The source of light is what? It's the sun, right? The sun is behind the moon. It's not right behind the moon. Point of confusion for people looking through telescopes first time is figuring out how far away are things. Well, the moon is 400 times closer to us than the sun, roughly 250,000 miles. The sun roughly 100 million miles. You know, so 1/4 to 100, ratio 400 to 1. The sun is 400 times bigger than the moon, roughly. Right? The actual figure, 93 million miles away. But, you know, just speaking roughly, that's why the two look the same size in the sky. Interesting coincidence. When the moon in its orbit around the Earth passes close to the sun that is in front of the sun, right? It's still 400 times closer. It's not lit up very well. We're seeing the side that's not lit, which happens to be The side that is lit when the moon's all the way on the opposite side of its orbit, the full moon, right? So there is no such thing as a dark side of the moon. Every side of the moon, at some point or another, will be light and will be dark as the moon goes through its cycle, its orbit around the Earth. Every part gets lit. It just takes longer than the Earth. As the Earth spins around 24 hours, the moon takes about 29 and a half, actually 27 and a third days to orbit the Earth. And we see it as longer if we go by calendar, because as the moon moves around the Earth, it's also moving around the sun, which complicates matters and makes the calendar moon 29 and a half. And then to make matters even worse, the Roman emperors jiggered the days, moved them around, and added more days for their months. Like Augustus Caesar took 31 for his month, August. All complicated. For those of you who are mathematicians in the audience, I know there's raise your hands. Very good. Universal time is how we note events in astronomy. The new moon happens exactly at 1908 universal time, the time at the London Greenwich Observatory, the prime meridian. We are to the west, right? United States, west of England. So we get the sun after they do. As the Earth rotates into the east, the sun rises in the east, sets in the west, we get it 4 hours later. So our time in 1908 is 4 hours earlier. 19 minus 4 is 6, 18, guesses, 1508. And we all know that's how we all describe time, right? 1500 hours to military time. You want to convert that to AM or PM, subtract 12. 1500 is going to be in the PM always. Anything bigger than 12, 15 minus 12 is 3, 3:08 PM Eastern Standard Time is a new moon. I know, by now you're all wondering, so what? What's great about the new moon? If you do look at the sky when the moon is new at night, it's going to be as dark as possible. The moon's light interferes with finding faint objects, galaxies, star clusters, right? Not planets, those are bright. But everything else is far away, it's dim, the light is spread out, diffuse. You want to see nebulas? You want to see galaxies? This is a great thing, right? -4, 4:19 in the morning. Exactly. And that's when the moon is exactly in a line, sun, Earth, moon. Now, as the moon goes around the Earth, why don't we see it go into the Earth's shadow every month? And why don't we see it going in front of the sun?
Hey, Lonnie.
And I'm going to pause everyone for technical catching up. There are bandwidth issues, folks. As you probably all know, doing everything online does have its disadvantages. I am not using a super fast connection. It's pretty good, but we'll wait. I'm going to wait for the go-ahead. So let's see, I could tell you stories about things that have happened to me when I was observing the sky. Most of the time, clouds. Very disappointing. Can you see through clouds? Let's see, you had a super duper telescope like the 48-inch being constructed at UACNJ observatories. And the answer is, nope. Can't see through clouds with an optical telescope. Light does not penetrate clouds, as you well know if you've ever been caught in the fog. But radio waves, longer wavelengths, do penetrate clouds. So radio telescopes see through clouds, and that's how we first mapped the surface of the planet Venus from the Earth with radar. Just penetrated right through those Venusian clouds. Patrick Moore, famous writer, wrote that Venusian is such an ugly word. He preferred the ancient name for Venus, Cytherea. So he called them Cytherean clouds. What do you think? Prettier? Same problem with Mars. Martian sounds kind of ugly. And that's why we call people who study Mars, formerly known to the Greeks as Aries, we call Martian geologists Areologists. A-R-E-S, Aries. There's a lot of cool history to astronomy. I urge you to check it out. So we're waiting until we get to go ahead so that you can all see what we're doing. Now, let's say you went outside. Well, my wife will tell you I ramble all the time, and that was just in case there were people listening, but I will be quiet for a bit. All right, thank you. Thanks, Jeff and Chris and Kim, for all the hard work. Appreciate it. So I was talking about the new moon and full moon this month. Check that out. There's not a whole lot otherwise going on. And next time, I'll be talking about when Mercury is best visible in the morning, the innermost planet Mercury. Guess which talk I'll be presenting that at. What's up in the March sky? I'm going to use a free program called Stellarium that's free to install just about anywhere. For you good people in the audience, try it out. It lets you simulate the sky from anywhere on the Earth. And we're not going to do it here. We're going to do it in Stellarium. Let me make sure that I'm sharing that screen. Let me know if you don't see stars in a simulated sky. Stellarium is a free program that lets you zoom in, zoom out. It's like having a living, active star map. And you're facing the letter N for north because that's a good place to start getting oriented to the sky. There's some very recognizable star groupings here. One of them is famous. It's an asterism, which means a star picture, that's not a full constellation. A constellation is officially recognized by the International Astronomical Union since 1930, which, if you think about it, is not that long ago, right? We didn't have official names for all the constellations for centuries. People just made up all kinds. I can cheat in Stellarium and actually draw lines between the stars so that you might see the head, claws, and tail of Ursa Major.
Hey, Lonnie,
Great Bear.
what screen are you
Ursa
showing
Bear,
right now?
Major, large, the large bear. There's also a small bear, you guessed it, Ursa Minor. You're not
Hey,
going to
Lonnie.
see pictures in the sky. It's going to be a lot harder to find things. And, question?
Yeah, we can't see the screen
Okay,
that you're
you're not also
sharing.
going to see lines. And you're not going to see the stars small. Okay. So I was talking about the star patterns. Some of them are asterisms, like this famous one here. 7 stars, actually 8 if you look carefully. In the bend of the handle of the Big Dipper or Great Bear, you'll see an eighth star, the famous double star. And the whole thing, if I zoom out, you'll see the whole thing makes a constellation now. Big Dipper's part of the Great Bear. Little Bear, right beside, famous Little Dipper, Little Bear, Ursa Minor. And we can use a technique that we amateur astronomers, but it takes them thousands of years to change positions so that we can notice. Stick around a few thousand years, you'll see the star patterns change. Mars moves right through the sky, and so the ancient Greeks called them planetides, wanderers, and you can see where the word planet comes from. If you face more due south, you'll see some of the brightest stars of winter. There's something called a winter hexagon. I like to look at the winter triangle of bright stars, a reddish star, Betelgeuse, a bright yellowish star, Procyon, and a bright bluish star, Sirius. This is the second closest star to us in the sky, and it's consequently the second brightest star. Second brightest star. What's the first? Is it Betelgeuse? Is it Rigel? Both in Orion, the hunter, kind of looks like a hunter holding a shield, an animal skin. Can you see him? Belt holding up a sword. One of the most easily recognized constellations. Sirius is the second brightest star in the sky, 8 light years away. The sun is 8 light minutes away. So if we would turn off Sirius, we wouldn't know about it for 8 years. Turn off the sun, we wouldn't know about it for 8 minutes. Distances are huge in space. So you can see some of the distances in Stellarium. It's really cool. The stars of Orion's belt, Alnitak, Alnilam, and Mintaka, 800 light years. Close, 19, almost 20, and 900. So some of these are accidental alignments. This one is much closer to us. And so they happen to line up as 3. But if you went to the side of these stars, that is out into space, about 19 light years, this middle star would disappear from Orion. Cool. Betelgeuse, you know what this is? I was told very politely when I was a kid, the shoulder of the giant Orion. Very noble shoulder. Oh, it kind of looks like shoulders, right? Well, actually, Betelgeuse or Betelgeuse or Betelgeuse or Betelgeuse, there are different ways to pronounce it, literally translated means the armpit of the giant, the armpit. And recently, just within the last couple of years, Betelgeuse got noticeably dimmer. It was dimmer last year than I've ever seen it in my entire life. We think that some huge cloud of dust got in front of it, or maybe the star itself, which is unstable. It's an unstable variable star. Maybe part of it puffed away, or a part of the gas is cooled and obscured the light temporarily. Betelgeuse is on the way back to being bright again. Check it out. One of the most famous areas of the sky, the belt of Orion, with a pair of binoculars, you can tell that there's a fuzzy cloud hanging in the middle of the belt. You can actually see it in binoculars. Does not have the bright colors we see here because the human eye with low light levels is not very good at seeing color. But here in long exposure photographs or images, I don't know if we say photographs anymore. Anybody know what a photograph is? Anybody know what photographic film is? How about slide rule? How about rotary telephone? Wow, this guy's old. What is he talking about? You whippersnappers, you hooligans, you so-and-sos, get off my lawn. The Great Nebula of Orion. You've heard of that, haven't you? That is one of the most famous stellar birthplaces, a cloud of hydrogen and dust. Hydrogen glowing in its own light, red. The blue light from blue, young, hot stars like Sirius reflecting off of gas. In the dark lanes of dust, black. Someday all this will collapse to form new solar systems, and perhaps in 1 billion years or more we'll have another Earth forming. There could be billions of Earths, as many as 10 billion in our galaxy alone. And we now think the universe may consist of 2 trillion galaxies in the part we can see. But the part we can see is probably only a few hundredths of the entire universe. As Douglas Adams said, space is really big, very profound. So get a small telescope or come to UACNJ and look through the different telescopes. One of them is named after me, shameless plug. Go and look through it and see what these objects look like in different telescopes, different magnifications, different amounts of light. It's fun. Astronomy is fun. There's many ways to view these objects. Some of them are far away, thousands of light years. They're fuzzy, they're cloudy. They're called deep sky objects. And can you tell what this one looks like? Beautiful in Monoceros, the unicorn, mono, one, ceros, horn, right? Rhino, nose, oceros, ceros, rhinoceros, horn nose, literally. This is called the Rosette Nebula, Rosette Nebula. Beautiful stellar birthplace, glowing in the light of hydrogen gas. Lots of beautiful things to see. The amateur astronomers at Jenny Jump, at the Jenny Jump and Hope at the UACNJ observatories would be very happy to show you the sky. The only thing that I ask you not to do is please do not kick their tripods. They spend a great deal of time setting the mounts of their telescopes so that the telescopes can track the sky. And if you want to see an astronomer cry, you don't. Please don't kick the tripod. Can you see the hair Lepus, leaping beneath Orion. So it's fun to star hop around the sky. You can use Orion's belt to hop to two other prominent features in the sky in a straight line up and look up for the face, the Hyades, an old star cluster, the face with a bright red eye star Aldebaran, Alpha Tauri. What is Taurus? Anyone? Anybody born under the sign Taurus when the sun was there? The bull, zodiac sign. The signs of the zodiac mark where the sun, moon, and planets travel. Because the solar system, my friends, is kind of like a dinner plate with peas rolling around in orbits around the mashed potatoes in the center. Yep, it's, as we say in the scientific term, flat. The solar system is flat, except for Mercury, tipped a bit, and Pluto tipped a lot. Pluto is not really considered one of the major planets anymore. It's a dwarf planet in a kind of a class of its own. It's the first discovered of the dwarf planets. It's one of the brighter ones, but it's not the biggest. Sedna is even larger. Clyde Tombaugh was just lucky to find it in 1930. Follow Orion's belt again to the west, past the Hyades, and you'll see what many people mistake as a little dipper. This kind of a dipper shape, it's a younger star cluster, still glowing blue from the light of the hot blue young stars, much hotter than the sun. The sun can be about 5,000 degrees Kelvin. Absolutely. You know what? At that point, 5,000 is pretty close to Celsius or Kelvin. These stars can be twice that or 4 times that. The seven sisters, 1, 2, 3, 4, 5, 6, 7, and some of you might have sharp enough eyesight to see an 8th, or maybe even more. If you want to see a cluster like that, you've got to use binoculars or a telescope. So come on and we'll show that to you. But check it out. Go outside at night on your own, right? 9 o'clock, 8 o'clock, 9 o'clock at night. It's pretty dark in the winter. Winter skies are half a million years ago. And yet, that's not very long in the life of the galaxy. Our Milky Way galaxy is about 10 billion years old. The Andromeda galaxy, similar, at 2 million light years away. 2 million years is only 2,000ths of a billion, right? So that's not very long in the life of the galaxy. Andromeda looks as our Milky Way would from Andromeda, tipped at an angle with a couple of small satellite galaxies. We have 2 that some of you may have seen. If you've traveled south of the equator, you may have been lucky enough to see the clouds of Magellan, the Magellanic Clouds. These are actually mini galaxies that passed through ours several 100 million years ago and left a trail behind them. We can't see the trails of Andromedas, but on long exposure photographs and in different wavelengths of light, you can actually see the track from the collision. And eventually, all large galaxies will swallow up all their companions. The Milky Way has dozens, so does Andromeda. Many of them only recently discovered because they're hiding behind the center of the galaxy, off on the other side. We've finally been able to penetrate that with infrared, X-ray, and other observatories. Now, in about 3 billion years, we're going to merge with the Andromeda Galaxy. So we have little time not to. We become one giant super galaxy. And the 2 black holes at the center of each will become a massive super black hole. Stuff to contemplate as you look at the winter sky. And we're going to end up with a quick peek at the stars rising in the east, stars rising in the east, set in the west, just as does the sun and the moon. And look above Orion for the other zodiac sign with the bright stars, yellowish Pollux, bluish Castor. Alpha Gem, Beta Gem. What's Gem? 2 people who look alike, twins, Gemini the twins. You'll find the path of the sun, moon, and planets passing through here. In Stellarium, you can turn on this marking, which is called the ecliptic. So go out on the night, not tonight, maybe not Monday night, Sunday, Monday, I don't know, snow, right? But when it finally clears, look for the red line in the sky. It goes right by Mars. What? What do you mean there's no red line? That is correct. One of you in the audience was paying attention and has corrected me. You're not going to see this in the real sky. But you can see how Mars follows the ecliptic, the path of the Earth's orbit drawn out into space. For the moon, sun, and planets are pretty close to that. The moon is tipped a few degrees to the Earth's equator. So that's why it misses the sun and the Earth's shadow, and we don't have solar and lunar eclipses every month. We would if the moon was exactly aligned in its orbit with our equator. Past Taurus the bull, past Gemini the twins, past Cancer the crab, past Leo the lion. Another one of the few constellations that almost looks like what it's supposed to be. See it? Backwards question mark for the name. Bright star Regulus, the lawgiver. And so you've got a quick tour of the night sky there. I think I may extend it a little bit because we're having technical difficulties, but just a little. And we can do a quick review towards the end. If you look very high in the sky, high above Taurus, you'll find Auriga, the chariot rider. Looks just like a guy in a chariot, right? You know, what am I on? He's supposed to be carrying some baby goats. You see them right there? One of these stars is a famous star, Zeta Auriga, super giant red star with a little dwarf star orbiting actually within it. It's so big. Bright star is Capella, Alpha Auriga. And if you trace the constellations, Auriga, Gemini, past Orion, down past the little dog, past the big dog, you will be looking at our Milky Way galaxy, the light of so many stars, about 1 trillion, that's 1,000 billion, that's 1 million million, that's 10 followed by 12 zeros. That's how many stars we now know are in the Milky Way, newly discovered. We have many, many red dwarf stars discovered by the Kepler Space Probe and other Kuiper probe, new one, studying the eclipses that planets make when they pass in front of these stars. And so we've discovered there could be as many as, or speculate, as many as 10 billion intelligent civilizations in our galaxy. But at what level? Are there cave people? Are there people who have had space flight for 1 million years or more? Maybe we'll find out someday. It's fun to contemplate the universe. Check out the Milky Way, the light of a trillion stars, thousands of billions. From UACNJ's observatories, very often the sky is dark enough that you can still see the Milky Way with the naked eye, from horizon, where the sky meets the ground, to the other horizon, all the way on the opposite side of the sky in the time.
Yes, we
1 month
can
later.
currently see that. Thank you.
Oh, thanks, Kim. Going back and forth 1 month, watch what happens to the planet Mars. Right near the Pleiades. It's going to make a nice grouping on March 1st. Don't miss it. But if you were to look at the same part of the sky, hold your head lined up with something like a telephone pole, a house, in the same part of the sky. In 1 month, the sky has shifted quite a bit. This is why we at UACNJ, United Astronomy Clubs of New Jersey, do a talk every month called What's Up in the Sky. And so next month, it's What's Up in the March Sky. And I'll be reviewing the winter triangle of 3 bright stars, as well as the stars coming up of the late winter and early spring. So that's using stellarium. For those of you who have larger telescopes, or even a small telescope, can see the first planet that was discovered, Uranus, the planet after Saturn, Uranus or Uranus, it can be said several different ways, very small little disk. Mars showing about 8 arc seconds. A second of arc is an angle, right? A second is 1/60th of a minute. A minute is 1/60th of a degree. So a second is very tiny. Mars is 8, Uranus only 3.6. Very hard to see any details on this planet, but it's fun to try to find the outer planets. So when you do visit UACNJ Observatory, by the time you do in April, this part of the sky probably won't be visible, but you can ask the astronomers to show you whatever planets are up in the sky. And eventually, within another year, you should be able to find Uranus again when the sky is dark. Right now, it's very close to the planet Mars in the sky. Does that mean it's close in space? No. Mars is about 1.5 in its orbit, 1.5 times further away from the sun than the Earth on average, but it has an eccentric orbit that carries it closer to and further away from the Earth. So right now, Mars is something more, it's more than, well, it's around 1.5 times the Earth-Sun distance. That's how we measure things in the solar system. Uranus at 19 times, quite a bit further away. Another program you can use to fly through the solar system, very fun to simulate, is Celestia. Google it or DuckDuckGo it. Anybody know about DuckDuckGo? The browser, the search engine that doesn't track you the way Google does. Check out Celestia. And now, you thought you might get away without homework? Well, wrong you were, because the first thing you might want to do as a good reference is UACNJ.org. UACNJ, United Astronomy Clubs of New Jersey. We are an umbrella organization of many different astronomy groups in the state, as well as some from Pennsylvania and New York, our neighbors, who also have some very dark skies. UACNJ, all kinds of events, our talks, not just What's Up, but all about black holes and gravity waves and planets and observing in Antarctica, fun stuff. For those of you who like to read, I know there's not many of us left anymore. There are magazines in print and online. Sky and Telescope and Astronomy, published for decades, are aimed at people like you and me, lay people, amateurs, right? We're not professional astronomers, but we can learn just about as much as they. We just don't get paid. Programs, apps, Stellarium, Celestia. And then I found 10 free apps for your phone or tablets. If you have a flexible phone, I guess it'll be a flablet. Anybody have a flablet out there? I used to use Skyview, and that is free. Skyview Lite is free. Hold your phone up, the GPS system in your phone will show you what you're looking at and identify it. It'll actually follow the sky. You point in different directions. It will know what it's looking at. Very cool. And lastly, I belong to an organization of astronomical artists that's international, the IAAA. If you go to IAAA.org, you can see great artwork by my colleagues. There are only about 200 space artists in the world. And my site is linked there, astronomyinmotion.com, which my wife helped me name. And that's the two of us at Niagara Falls. Astronomyinmotion.com also shamelessly advertises my book, Space History Mystery Solved, which uses your fingers to interact with 3D models on your screen, on your phone, on your phablet, on your computer, or with a mouse or a pointer, interactively to show how the canals of Mars, what made the canals of Mars, and what did they see of the planet Mercury early on 100 years ago? And what was that explosion on the moon? Lots of mysteries. There's a new one to add for me. I got work cut out for me. The mini moon, 2020 SO. What was it? Where was it? They lost it for 50 years. It came back last year, and now it's left us. Farewell, 2020 SO. I'm going to put you in my book. I want to thank you for being a very patient audience, especially through our technical difficulties. I'm going to go back a couple of screens to the references so you can jot them down with old-fashioned communication devices like pencil, I'm not sure what that is, and paper, I'm not sure what that is, or your technological devices, or your memories. And so I'm going to say thank you, and I'm going to wait to see if we have questions. You've been a very good audience. I look forward to meeting some of you in person, all of you, if you wish. If you can visit us at UACNJ Observatory at uacnj.org in Hope. And we do have directions on the website, as well as many other references. I want to especially thank Kim and Jeff and Chris, our technical team, for working with some very difficult conditions to bring all of you, my friends, this wonderful series. And I hope to see you again for not only What's Up in the Sky, but all talks at UACNJ. Thanks.
All right. Thank you so much, Lonnie, for a great talk. Normally, when we would be doing this live, we would have a quick Q&A section. Because of the technical difficulties, we did lose our live chat. However, I did go around and collect some questions from people who had been watching.
Great.
One of the questions being, are there theories as to why the solar system is mostly on one plane?
That's a great question. Yes, and for many decades there were theories, especially when I was growing up. But now we have supercomputer networks with more random access memory than the human brain, which has about 1 trillion bytes. And those supercomputer simulators can simulate with increasing accuracy all kinds of collisions and things that happen in the early solar system. And not only can we simulate it, but we can actually observe star systems for the first time. We can see the circumstellar disks of gas as they form, and they are indeed flat. What happens is the other orbits tend to collide and cancel each other out, so that eventually, due to the physics of the situation, especially angular momentum, what is left is relatively flat and stable in a disk around the equator of a star. I can't explain the math to you. I don't understand entirely myself, even though I have a degree in physics. I would have to review the math to get that level of detail. But it's basically because that's what's left after everything collides. That's a simplified way to explain it. And so for the most part, our solar system is flat for the major bodies. However, don't take my word literally, because the comets come in from a vast cloud called the Oort cloud, which is spherical at all different angles. And that's why they come in at odd angles to the orbits of the orbit of the Earth and other planets. Asteroids pretty much are same plane. We've had some odd visitors like Oumuamua coming from outside the solar system. They can come in at any angle, any angle. And then there are some dwarf planets that have interacted with others and got thrown into weird orbits, like Pluto. Pluto is tipped quite a bit to the plane of the Earth's orbit. So that's an excellent question. Thank you, and thanks, Kim.
All right. Also, a bit back, you had mentioned that winter was better for imaging in the Northern Hemisphere, especially where we are at UACNJ. Why is that? And the second part to that question is winter being better for imaging local to our area in New Jersey or true for many places?
Oh, both excellent questions. But to answer your second question first, this applies to anywhere on the Earth, actually, anywhere. And that is because there's something that we amateur astronomers call seeing, the quality of the images to our telescopes is affected by the atmosphere, incredibly. And that's because the light coming from stars is so far away that the light is in a very thin beam. It activates very few cones, maybe one cone cell in our eye, and so it can be interrupted by the slightest things, even air currents. You know, if any of you have flown in airplanes, you know that air currents can have a sizable effect, but it doesn't have an effect on starlight. So the reason that winter is good is because the atmosphere tends to be steadier, more stable in the air when the air is cold. It's not as turbulent. It's not heated up. The air molecules are moving more slowly. And turbulence, it takes longer and greater effort to develop. In the summer, you have all kinds of convection currents, heat. That's why you see those storm clouds growing, giant columns of clouds from the convection currents, from heat rising air molecules, and air expands as it rises, making for further turbulence. So winter, even though it's not convenient for we human beings who have to stay warm, it is a good time to observe. And it does apply universally, not just at UACNJ Observatory. Now, if you want to get even clearer skies, you go to where it's high, mountaintops. And that's where they're building the world's biggest and greatest and newest telescopes, high up where the air is thinner, less turbulence, less air to get through. And this was recognized as early as the late 1700s, the 18th century and earlier, by Isaac Newton himself, who wrote that the air is of a finer quality at the high mountains. He phrased it in very flowery language. Look up Isaac Newton and Isaac Newton's comments on seeing and the atmosphere. It's very entertaining. Thank you.
Very nice. And I have one last question based on a viewer's rather immature question that I shall not voice in public. Um, is it possible to see the other outer solar system planets in telescopes at UACNJ? Most of us are aware of Saturn and Jupiter, which are pretty even naked eye visible, but anything past that is what they are asking about.
Yeah, actually, we read many years ago that a 12-inch diameter telescope, diameter now, not length, but we're talking about the size of the lens or the mirror. Most telescopes at Jenny Jump use mirrors to reflect light back to another mirror and then to the side to an eyepiece where you could look. Some telescopes use lenses. Those are more difficult to figure correctly. So the bigger lenses have a lot of weight to them, a lot of glass. They're a little less common. So well, I lost track of what I was going to say. If you could refresh my memory before I lose the question entirely, I tend to ramble.
All right. I had actually asked one of our imagers from UACNJ, and they did say you can see visually Uranus and Neptune and Pluto photographically, mostly because you can kind of resolve the disks to see that Uranus and Neptune are planets. However, Pluto is just a little bit too dim and too far out to do that visually, but you can get it through photographs.
In fact, the world's largest telescope at the time, the Mount Palomar 200-inch, for many years, for decades, the largest telescope, they limited the size of Pluto to the limit that that telescope could see, which is about a quarter second of arc. And so they thought Pluto was 8,000 miles across, same as the Earth. It turns out it's more like 1,500. It's tiny, smaller than the moon. And that's because the atmosphere tends to limit things to a quarter, actually about a half second of arc. Under extraordinary seeing, you might get a quarter second of arc. So the largest telescopes at Jenny Jump, at the observatories, they're not going to do better than a 9-inch telescope because of seeing, unless the sky is really steady. And sometimes you get rare moments when it does steady. So Pluto is possible. It has to be in the right part of the sky, and you need a big telescope. That's a good question.
All right. Unfortunately, that is the end of the questions I was able to collect from the chat members who unfortunately got kicked because of technical difficulties. I would like to thank you, Lonnie, for joining us. I'd also like to thank our audience who was live at the time and apologize that we were not able to keep our stream live. But this whole video will be available. We're going to take the first half and the second half that kind of fell apart in YouTube and stitch them back together and have that link up on our Facebook and our website shortly, uacnj.org. We also want to remind you, thank you everyone for tuning in. Don't forget to hit that follow and subscribe buttons down below for more great live stream goodness. And check us out to our social media, Facebook, Instagram, Twitter, and also remind people that through our website you can donate. We are a nonprofit organization, and all we get no money, but any money donated does go to paying bills and upgrading our equipment. So hopefully that the technical difficulties become less and less, and help us keep offering the free public programs to you guys. Uh, Anyhow, thank you all for joining us. And until it's astronomy time again, good night.